Hey yo, what up, what up? We are in the last video for plate boundaries. Yeah. Now for this video, we're gonna be discussing the last type of plate boundary, which is called, of course, as the transform plate boundary. Mhm. Now, this type of boundary is not constructive and it is also not destructive. Okay, the constructive type of plate boundary again is yes, the divergent boundary wherein new tectonic plates form at the ridge, and a destructive plate boundary is where there is a convergent boundary because again the subducting plate is going to be recycled in the mantle. So for transform plate boundaries, none of that happens because the two tectonic plates just slide past each other. And let us quickly go over the concept notes on what it says about transform plate boundaries. Okay? It says here, when two divergent plate boundaries are adjacent to each other, adjacent meaning they are next to each other, a new type of boundary is called a transform fault boundary. So, how would this look like? Let's go through the file one more time. They are most transform join two segments of middle channel. Increase the presence of indication of the and the two places divergent into two segments. Let's just quickly draw what that means. So, let's say for example, I am going to have a plate. This is gonna be a bird's eye view, a view from the top on how that will look like. Again, what type of landform is formed in a divergent boundary? It's called a ridge. So I'm going to draw two ridges. So over here, okay, these are two tectonic plates. Over here, two tectonic plates. They're moving away from each other. Okay, moving away from each other. This here is the ridge over there. So, pag ganun, yung movement. And then, we talked about two divergent plate boundaries adjacent to each other or being next to each other. So, let's just add another plate boundary over here. Let me just continue drawing that up. So this is the plate boundary. This plate over here and this plate is going to the opposite directions. Again, this here is the ridge. So right now we have two adjacent divergent plate boundaries. Divergent plate boundary A and divergent plate boundary B. Now, since they are adjacent, look at this area over here. You can notice that the two plates are next to each other, tapad sila. And you will be also able to notice that the two plates are going to grind past each other over there, over this area over here, because they're moving on different directions. This plate is being pushed towards here because of the ridge push that's happening here. And this plate is being pushed towards here because of the ridge push that's happening here. Because of that, a new type of plate boundary is formed. This here is the transform plate boundary. Some students usually ask, so sir, ano mangyari dito? What happens to these two plates that are moving? Technically, they will just move sabay because these two plates are moving in the same direction. Nothing will happen. They just continue to move, being pushed by the ridge push, by the divergent boundary. Our main concern is this new boundary form over here. So let me just illustrate that one time all over again. I will draw a ridge. This is the ridge. Again, a bird's eye view. This here is one plate and another plate. This plate is going here. This plate is going here. We have one divergent boundary. And then let's say for example, next to that is going to be another divergent boundary. This plate is going here and this plate is going here. Okay? a new type of boundary is formed because these two plates over this boundary are going to grind past each other. So this area is going to be our transform fault. Sir, are there examples about that? Let's quickly go back to the Mid-Atlantic Ridge. Okay? Let's quickly go back to the Mid-Atlantic Ridge. Over here, yes. This here is a really good picture, and this here is a really good example on how a transform fault boundary looks like. Let's just open this up. There. Now, over the Mid-Atlantic Ridge, you can see two colors. You have red and then you have yellow. So, yung red, yan yung divergent boundary. And then the yellow ones are the transform fault boundaries. Oh, ito guys. Ito yun. Ito yun. So, the Mid-Atlantic Ridge is actually a series of divergent boundaries and also a series of transform fault boundaries. So, as what we can see here, this divergent boundary is adjacent to this one, forming a transform fault boundary over here. This divergent boundary is adjacent to this one, thus forming this transform fault boundary over here. Okay, let's just zoom in a little bit more so that we can actually even see that. Okay, we cannot zoom anymore. This plate boundary here is moving this way. And this oceanic plate here is moving this way. And then this oceanic plate boundary is moving this way. And this oceanic plate boundary is moving this way. So, this area over here, these two plates over this boundary, this next plate, ito and ito, they are going to move against each other, thus forming this transform fault boundary. Okay? And there are lots more. There are a lot and a lot more divergent boundaries that are next to each other. And when they are next to each other, they form transform fault boundaries that grind past each other. Okay? Now, a good thing also to take note, most transform faults join two segments of a mid-oceanic ridge. They grind past each other. Because, look at this last paragraph. The immediate concern about there are earthquake activities triggered by movements along the fault system. So, these types of plate boundaries actually create one of the strongest types of earthquake, because sometimes, let's just a bird's eye view, when these two plates move against each other, sometimes or most of the time they get stuck because they're made of rocks. They're made of rocks, so they're highly irregular. So when they want to move, they get stuck. Okay? But ridge push continues to happen, so they keep on pushing against each other until there will come a time that the two rocks cannot anymore handle the pressure. They will break and cause a lot of vibration. Pang! Something like that. So like when I'm pushing my two fingers against each other, and then suddenly when my fingers cannot hold on to the pressure anymore, they suddenly move in a very big motion. That is how strong earthquakes are created. And one of the many ways how a very strong earthquake can be created is through a transform fault boundary.